Welcome back to the OpenVINO channel. Let's talk about the concept of the inference engine. We talked about the full inference flow in previous videos. We need to take a pre-trained model and prepare it for inference. This is an offline stage that is done by the model optimizer, covered in previous videos. The model optimizer can do all kinds of manipulations, as we previously explained. They are all hardware agnostic, so our starting point for the inference engine is the IR files. The inference engine is an API to integrate inside your own application. The API is common for all hardware devices, and we provide it in C++ and Python. Check out video 17 for the Python wrapper example. The model optimizer is processing the original model and mapping the primitives or the layers to the supported operations, which construct the IR files. In this example, I show a model with 3 layers, each has a different operation. The implementation of each of these operations will be different on each different device. Let's take the multiply operation for example. It is the same operation, but the implementation for CPU will be C++ or assembler. The implementation of the same function for the GPU will be written in OpenCL, and so on. So the inference engine has a different plugin for each of the supported devices. The CPU plugin will use the MKLDNN library, the GPU plugin will utilize the CLDNN library, and so on. The developer only has to specify the target device. The inference engine will use a right plugin and bring the right implementation of the network to the desired device. But it's more than just the mapping to the right library cells. When the network is sent to the hardware plugin before inference, hardware-specific optimizations at multiple levels are done. First, network level optimization. Some operations do not map to kernels, but to the relations between them and the rearrangement of the data. This can boost performance and minimize data conversions time during the inference. 2. Memory level optimization. Basically, rearrangement of the data in memory according to the specific device requirement. And 3. Kernel level optimization. The inference engine will choose the right implementation, which is the best for the instruction set architecture. So if your CPU can support AVX512, the implementation will utilize that. If it supports only MMX, this will be the implementation, and so on. So the basic concept is model optimizer is doing hardware agnostic optimizations. The inference engine chooses the right plugin for the right target device to perform device-specific optimization. So this is the concept of the Inference Engine API. On video 16, we'll show you the main API functions on a sample code. On video 17, we'll review the Python wrapper. And in future videos, we'll talk about many more features, like asynchronous execution, custom layers, etc. Subscribe to our channel to get more videos like this. Thank you.